Alright guys, so today's lesson we're focusing on titration. Work that is due today is classwork 1 and 2 at 11:59, as well as your homework, which is due tomorrow, Wednesday at 11:59 p.m. as well. Giving you a lot of time and a lot of breaks in this because I want you to, use your time wisely. Um, Here we go. So titration. Titration is a neutralization reaction that is used to determine the concentration of an unknown substance. Keyword in this is a neutralization reaction. Yesterday, when we went over neutralization, we said that neutralization is it's a reaction that occurs between an acid and a base that forms water and a salt. Now, titration is the laboratory procedure that goes with this neutralization reaction. But it also helps us find the concentration of an unknown substance. And that's what we're going to be focusing on today. Now, for us to be able to use titration, we need to know the concentration. We need to know a substance with a known concentration, and it has to be used with an indicator. That indicator could be phenolphthalein, dimethyl blue, methylene orange, universal indicator, as long as it's an indicator that can tell us between an acid and a base. We're good. So now titration helps us find the concentration of an unknown substance by using the concentration of a known substance to neutralize the solution. Now, for us to be able to do this laboratory procedure, we're going to need a birette. Now, a birette is, I like to call it, a long graduated cylinder with a knob at the bottom. Basically helps us measure how much of the solution we're using that's going into the known. Now, I'm going to show you how a breakdown of the solution is, the procedure is, and I'll with pictures, I'm going to show you how it's done or conducted. So over here, we have our known solution, right, with the indicator, and then we have our unknown in our birette. So we're slowly going to open that birette up, the stopcock, and it's slowly going to let solution, the unknown into the known. Now, when it comes in contact with it, we're going to have a brief color change, and this is because of the indicator. Now, our goal for this is to make sure that this color change is permanent. Now, some of us like to swirl the flask. Some of us like to swirl the flask as the unknown is entering the solution to disperse the ions around. That is possible. Do that as well. And then once the color change becomes permanent, we close the stopcock and we take note of the amount of volume we've used of our unknown. And then we're going to use the titration formula to help us calculate the concentration. So this is just not a laboratory procedure that you don't use a mathematical side. You're just not automatically going to get the concentration out of nowhere. You need to use the formula as well. So this formula, talking about this titration formula that comes with this titration method, we need to be able to say that this is the equivalency point. Now, the equivalency point is where the moles of unknown is equal to the moles of known. Let me say that again. This is where the moles of the unknown is equal to the moles of the known, or the moles of the base is now equal to the moles of the acid. That's where we have that permanent color change, right? So that is the equivalency point vocabulary, right? But like I was saying, we need to know the mathematical procedure that we need to do to follow to be able to calculate this concept, to be able to finish this titration process. So before we can even talk about that, we need to talk about molarity, because when it comes to titration, molarity is key. Concentration is very much key. So molarity is the measurement of concentration of a solution. Molarity is the amount of moles of solute equal per liter of solution. The formula is molarity equals, or M, capital M, equals moles divided by liters. This can be found on table T of your reference table. Now, because titration has to do with molarity, aka concentration, we need to make sure that we can practice molarity. So here we go. What is the concentration of 2.50 milliliters of 0.6 moles of HCl? I know this is a molarity problem because it's giving me concentration down here. It's stated very clearly that I'm dealing with concentration. So I know I'm going to be using this formula. Now, for this formula, I need to have moles, and I need to divide that by liters. So I have my moles here, 0.6 moles, but I do not have my liters. I have milliliters instead. So I'm going to be able to convert my milliliters to my liters because 1 liter equals 1,000 milliliters. So I'm going to take my milliliters and I'm going to go ahead and divide it by 1,000. So 250 divided by 1,000 gives me 0.25 liters. And then now that I have my liters and I have my moles, I'm going to plug them in and solve. So my moles were 0.60 divided by my liters, which is 0.250, and I get my answer as 2.4 moles per liter. Now, the problem is not always going to be that simplistic. Not always going to be that simplistic. So second problem over here, what volume of 0.7690 molarity LiOH will contain 55.3 grams of LiOH? Now, because they gave me molarity, that means they want me to use the molarity formula. So here's my molarity formula. Moles equal liters. Now, I have molarity, but I don't have moles and I don't have liters. So basically, I can't use this formula. But then I remember I can get moles by using my mole calculation if I'm given a mass of my substance. So I'm given a mass, which is 55.3 grams. I'm going to use the mole calculation to get my moles. Now, 55.3 grams is my given mass divided by my gram formula mass. My gram formula mass is, which I can calculate because I have 1 Li, 1 oxygen, and 1 hydrogen. Li has a mass of 20, Li has a mass of 7, oxygen has a mass of 15.99, which will round to 16, and H has a mass of 1. So 1 times 7 is 7, 16 times 1 is 16, 1 times 1 is 1, so 16 plus 7 plus 1 would give me 24. So I'm going to do 55.3 grams divided by 24 grams per mole. And I get 2.3 moles. Now that I have my moles, and now that I have milliliters, I can go ahead and find the volume, because that's what they were asking for. They were asking for the volume. So I plug in to the solution, and then over here, when in doubt, I'm going to go ahead and cross multiply. And when I cross multiply, I'm going to get 0.7690 x equals 23, 2.3. And then I'm going to divide 0.7690 from both sides, and I get my liters, or my volume, should equal 2.99. Alright, one more practice problem for molarity. So, calculate the molarity of a solution prepared by mixing 1.5 grams of NaCl and 500 milliliters of water. Very easy, very simple. Once again, they're asking me to calculate the molarity. So there's my molarity formula. Molarity equals moles over liters. Now, because they gave me my grams, I can use my mole calculation to find my moles. My given mass is 1.5, and now to find my gram formula mass of NaCl, I know that Na, I have 1 Na, 1 Cl. Na has a mass of 23, Cl has a mass of 35. So 1 times 23 is 23, and 1 times 35 is 35. We add those together, 23 plus 35, we get 58. So my setup is going to be 1.5 grams over 58 grams per mole. And my moles should be 0.0258 moles. So I have my moles. Now I have milliliters, but I need liters. So I'm going to go ahead and divide my milliliters by 1,000 to get my liters. And I get 500 divided by 1,000, which gives me a liters of 0.5. So now that I have my moles and I have my liters, I'm going to go ahead and plug them all in to get my molarity. So my setup should be 0.0258 moles divided by 0.5 liters. And my answer should be 0.0516 moles per liter. So that's how we work with molarity. And that's how we work with concentration. Let's go back to titration. So, To calculate the unknown concentration and titration procedure, we use the formula M1V1 equals M2V2. It's a proportional problem. So as long as we know it's proportional, we're going to be multiplying, then dividing towards the end. M1 is the first molarity given. V1 is the first volume given with the first molarity. This can be in milliliters or liters, up to the problem. M2 is the second molarity given. And then V2 is the second volume given with the second molarity. Once again, could be milliliters or liters. Hint: this formula can be found on table T of the reference table, so do not worry. The key word is neutralize or titration. Once you see these keywords, you're using this formula. Some of us are like, how do we know when we're using this formula? Once we see the keyword neutralize or titration, we are using this formula. So let's try a couple of problems with this and we're good to go. So, how many milliliters of a 3 molar NaOH solution are required to completely neutralize 20 milliliters of 1.5 molar HCl? So, I know this is a titration problem, not because I said it's a titration problem, because I see this word neutralize. So, I know it's a titration problem. Now, I have my molarities highlighted in purple, and then I have my liters, or my milliliters, or volume, highlighted in green to give me myself a hint. Now, I know I'm working with this formula, so I have this formula down. And then I know this is the first molarity or concentration given. So I'm going to take a note of that. Right? And then this is my second concentration given, so I'm going to take note of that. And this is the volume written with the second concentration, so it would be V2. So my setup should look something like this. 3m times V1 equals 1.5m times 2 milliliters. I know that these go together because I always like to say they're written together. So if they're written together, they're for the same side. Then we're going to simplify. 1.5 times 20 milliliters. And we simplify, we get 30 on that side, on my right side. And we get 3 molar times V1 on my left side. Now, we want to get V1 by itself. So we're going to go ahead and divide both sides by our 3 molar. And when we divide each side by our 3 molar, V1 should finally be by itself. And our answer should be 10 milliliters. And that is how we do this. All right. Let's try another one. What is the molarity of a solution of LiOH if 15 milliliters of the solution is required to... Okay, hold on. Sorry about that. Okay, this one's already up. What is the molarity of a solution of LiOH if 15 milliliters of the solution is required to neutralize 20 milliliters of 2 molar HCl? So this one's a little different than the last one because for this one, they give us one volume first. Then they give us another set of volume with the concentration. Once again, if they're written together, they're for the same substance. If they're written together, they're for the same substance. I know that this is a neutralization problem because I see the word neutralize right here. Or a titration problem because I see the word neutralize right here. So I'm using this formula. And because this are written together, it's for each other. So, or it's for the same side. So my setup, and sorry I didn't blur this out, but I guess I was working on something else. My setup should look like this. M1 times 15 milliliters equals 2m times 20 milliliters. Right? Now, I can't do anything on my left side, but on my right side, I can multiply the 2 by the 20 and I get 40. So when I simplify, I should get M1 times 15 milliliters equals 40. I want to get the M1 by itself, so I'm going to divide both sides by 15. And my M1, my first molarity, should equal 2.66 molarity. All right, last problem before we end. All right. What volume in milliliters of 0.25 molarity acetic acid is required to neutralize 30 milliliters of 0.05 molar of cesium hydroxide? Once again, I see this word neutralize. That means it is a titration problem, right? Now, I have my first concentration here, but it's not written with a volume, so that's going to be my X. And then I have my second concentration here, and that's written with a volume, so that's going to go on the right side. Then my setup should look like this: 0.25 molar times V1. I'm going to simplify, and then I divide on both sides, and there I go. And my answer should be 6.